In discussing artificial intelligence, one of the challenges is to understand, well, what's really going on? Very few people really have a basis for understanding what artificial intelligence actually means. It's not Skynet, it's not robot armies, and it's not something that will eventually just take over without any influence or impact from us. But fundamentally, what's happening is that data science is being transformed because of artificial intelligence. What AI enables are powerful tools which give us the ability for analysis and perhaps the ability also to be more accurate, less biased, and have really effective prediction tools. That's the fundamental goal. And what we're seeing in a couple areas, and I'll say artificial intelligence and transformation, where data science and accuracy is really the key. One of the things that we looked at in the past is computing power and data. And when I studied computer science, artificial intelligence was just considered theoretical, right? It was something that we'd never have the computing power, we'd never have the data that could make this useful. Well, we do. And what's happened is we have this transition for data analysis that's gone out from local processing. Now we have the cloud, and we have the ability to access really interesting processing power. We can access data, obviously, very broadly, and it's enabled us to get a feel for real results. But are those results accurate? We certainly can have a precision, but are we getting any accuracy, and are we getting anything that's truly useful? All right, so now that we have files that can be anywhere and data that we can collect from anywhere, putting all those tools together, processing, using the capabilities, but more importantly, really thinking is what's lacking. So when we think about now we have this cloud, we have all this data, we have all this information and processing power. Well, I call it, well, now we also have the haystack. Because where do you find value? Well, that's the needle in all this data and all this information, because we've obsessed about processing speed, we've obsessed about CPUs, GPUs, parallel systems, all of this stuff, which enables us to overcome that initial roadblock, which was, can we really process all this data? So we're able to gather this data, we're able to process this data, but is there any value there? So what are we getting that's actually useful? And this is much more challenging. And there are business models that are trying to use artificial intelligence to really generate any kind of value and capture it. Maybe the best example is Google, right? With the work of Andrew Ng at Google, they were able to, with their AI engines, produce more effective ads, right? So that's produced a very profitable business. We think about Netflix. Well, they're profiling the user and giving recommendations. And we think about Amazon, looking at your activity and giving recommendations. Now, if we step back, any of us who've used Amazon or Netflix, these recommendations are almost laughable, right? You see the inadequacy of these models because they come up with really silly stuff. What are they coming up with? Well, you bought a book on English history from the 1500s, and then you get recommendations for 10 more books on that topic. Well, that's pretty meaningless, right? And if you look at what gets fed to you, you do one simple Google search, and you're going to have ads permeating Facebook and Google and Amazon related to all of that, as if that's the only thing you're interested in, right? So the haystack is creating the ability to have speed to process things and give answers, but there's very little value that I think that is being captured. And so now we have to think about how can we be truly robust and comprehensive, but also fair. And fair really means an accurate depiction that is creating a useful tool. So one of the real challenges we have is that artificial intelligence is just based on probabilities, right? It is not definitive. It gives an answer, and so there's this illusion of precision and accuracy, but it's based on probabilities. It's based on usage. It's based on a lot of things. So it does learn because it gets more data, sees the outcomes. It's really like a Boolean analysis, right? So understanding that what that doesn't do is understand causality, right? That's the real challenge, because causality really does identify, okay, what are the inputs that when we process it through our systems, we get usable output. And that's really the key. What is usable in the information that's being generated? And many times what comes out, as we saw in the example of Netflix, Amazon, these kinds of recommendations, it's not really usable. And that's on a very small scale. So imagine on a grand industrial scale. And one of the real challenges that when it comes to understanding artificial intelligence is, well, what what is it again, right? We started off trying to figure out what it is, but even now I've heard these analogies from, pretty informed people that artificial intelligence is like electricity. It's everywhere and it'll be usable, it'll permeate everything we do. It's already beginning to do that. And I think that's a misrepresentation. It's not electricity. Electricity is an electromagnetic wave. It's very consistent. It doesn't change. It's not modifiable. It doesn't give biased results. It can't be manipulated. It can't be influenced, right? So AI is simply a tool, but remember, a tool based on probabilities, looking to understand causality. And that is a big leap. And we're not there yet. We're a long way away. But what gives me encouragement is that we are transforming the way we think about this. And people have identified these as issues. And now we have this sort of transformational thinking that will enable us to kind of look at, how to think like a computer scientist is what I call it. And now that's not computer programming. Computer science is not computer programming. And, Janine Witt at Carnegie Mellon, and now she's gone elsewhere, wrote a very interesting piece a while ago called Computational Thinking. And in it, it is thinking like a computer scientist, which is what can we understand, what is important, what really matters, right? And when we look at the factors, there may be 1,000 factors that influence an outcome, but what makes a difference? And that's maybe 1 or 2 factors, and maybe not more than 3. And so a computer scientist, or thinking like a computer scientist, as I call it, is that not everything is meaningful. Just because we can compute things, and that's one of the challenges, is we suddenly find everything is computable. Well, just because everything is computable and we can get an answer, that doesn't mean we found any meaning. And that's the real leap that we're looking for. We're looking for how do we find meaning, right? So we're seeing spectacular results and we're seeing great advancements in processing data. One of the great examples is what DeepMind was able to do in life sciences with understanding protein folding, right? So we all know that your body does something because a protein told it to do so. And a protein gets formed from a combination of 20 amino acids. And then those proteins then fold and they send specific signals. And it is just impossible to figure out how all this happens, right? But now we have a tool in what DeepMind has developed, which has now enabled us to understand this protein folding. And it's beyond what just human capability and reasoning could have accomplished. That's the big transition. I sort of use that as the vanguard of true value to come. So now we're seeing that instead of looking at an abstraction and looking at probabilities that are essentially meaningless, we now look at real understanding of causal effects. And we've gotten a way to now think about, I call it algorithmic reasoning. And the real key, anytime value is created, it's creativity. It's looking at a problem in a new way and coming up with a new solution. It's not just grinding through to get an answer. It's coming up with something that is truly useful, right? So in the case of DeepMind, that made a difference, right? And so now we're having, really human interaction with computer science-based tools, and that enables our truly great progression. The great progression is I've got a better tool to be more creative, and those answers are answers I couldn't otherwise accomplish on my own. And now we've got a combination of things that can create, a true transition in society. And I think